Hi students, you are welcome back to another interesting aspect in mathematics. And today we want to have a look at a very important aspect, which is bearing and distance. Now, more often than not, students usually get it difficult. But I want to prove to you today, or I want to show you that bearing and distance is very cheap. You are welcome on board. Now, in dealing with bearing and distance, there are some things you need to put into consideration. You must have gotten a basis in the concept of sine rule, cosine rule, as well as the cardinals. Now, in your lower levels, you were taught the sine rule. Now, where we have a triangle A, B, C. Now, in this triangle, this is the angle A. The side opposite in it is small letter A. This is angle C. Why this one is referred to as small letter C, distance C. This is angle B. This is going to be the distance B. And the sine rule says that the sine rule states that A all over sine A is equal to B all over sine B is equal to C all over sine C. That is the sine rule. Now, I did say that you must have the basis on the sine rule as well as the cosine rule. Now, this is the sine rule. Let's go to cosine rule. In cosine rule, let's say you have a triangle of this kind, where we have our A, we have our B, and of course we have our C. As we did to the sine rule, this is going to be small letter B. This is going to be the small letter A, while this is going to be the small letter C. In cosine rule, it states that supposing I'm looking for angle side B, this one will be square of B is equal to square of A plus square of C minus these two. That is 2AC cos of which side? That is now going to be the angle what? The angle B. Now, if you are now looking for side C, you now write the side that you are looking for first is equal to the sum of the square of the two other sides. That is A squared plus B squared minus 2AB cos C. The angle, it has to be a bigger value of C. Now, if you are looking for, say, A, you are looking for A, side A, we now have A squared is equal to B squared plus C squared minus 2BC cos of angle A. So, if these are understood, your problem is when do we use sine rule? When do you use cosine rule? This area usually gives students headache. When do you use sine and cosine rule? Now, sine rule is used if two sides plus if two angles, we have two angles. We have this angle given and we have this angle given. Of course, you can be given any side. Let's say I'm giving this side. I can use sine rule. That is, two angles must be known. If you know the two angles, of course, it's very easy for us to calculate the third angle. The sum total of angles in the triangle add up to 180. So if I know the two angles, of course, it is very easy for me to calculate the third angle. So thereafter, you will now apply this formula. Now, supposing I have been able to calculate this angle C, it's now going to be, it means one of the parameters I'm going to use is going to be C all over sine C plus the one they ask you to find. I hope you understand. From the one they ask you to watch to find, then you can of course use that. Or let us now see if I'm giving just an angle. You understand? And I'm giving a side here. Of course, here I cannot calculate it. Can you now see, class? Here I can say A all over A. Then here I have C. Okay, I have this C. If this C is given and they ask me to calculate this one, of course, it's very easy for me to calculate. Am I speaking? I know this, this angle is not known. I want to find this angle. I know this side, I know this angle, I know this side. Of course, I can calculate this angle. If I calculate this angle, I can get the other parameters. So it means we can now say sine rule is used if two angles and a side are known. I can use sine rule. If two sides and an angle are known, of course I can still, but mark you, the side that you know, you must know one of the angle of the side given before you can use sine rule. But let us now go to cosine rule. Cosine rule can only be used if you have two sides known. That is, I have a side, this is a side, I have another side, plus the included angle. This is the included angle. They must be known. That is, this side is known, this side is known, and the included angle, they must be known. If they are known, then you can do it. What am I saying? It means here, I'm giving this side. And of course, I'm giving this side. I'm giving this side. Class, which angle am I supposed to be giving? Of course, it's going to be this angle. Because this is a side, this is another side, included angle. This is the included angle. If I'm giving, I think that is understood. What about if I'm giving this angle? Which side must I be giving? I must be giving this side, which is C. And of course, I must be giving this side B. That is the included angle. I hope I'm talking. Then the next one, if I'm giving this one, where are the sides? I must be, of course, I must know this A. And of course, I must know this B. And this angle I've been given. I hope I'm talking. Now, that is the second point that must be known. Let's go to the. Now, the next one is the cardinal. Now, this is our cardinal. We have the cardinal. That is the north, the south, the west. How do we know the west? Your left hand side. Your right hand side is the east-west. The north, the south, the west, the east. Now, from north to east, we are having 90 degrees. From east to south, we are having another 90 degrees. From south to west, we have another 90 degrees. And of course, from north to west, we have another 90 degrees. So, meaning we are having 90 in 4 places. That is why they said angle at a point add up to what? 360. That is 90 times 4. Another thing is when you are starting your bearing, if it is not engineering bearing, we normally start from where? We start from north. And we move in clockwise direction. We start, take notice of what I said. We start from where? We start from north. And we move in a clockwise direction. Except you are otherwise told. That is how we move. Now, let me give you a very small example. If Shade moves from point A on a bearing of 70 degree to a point B. What is our bearing from B, from point B? Now, look at what the question is saying. They said if Shade moves from a point, look at the word from, that is the starting point. From here we have solution now. They said from where? From where did she start her movement? From point A. Start from point A. I will now write my A here. How did she move? She moves on a bearing of a what? 70. That is 070. 70. Well, class, let us now start. The moment you are giving something like this, you don't have any problem. Just label your cardinal. Our cardinal, we have north, we have south, we have west, and of course we have east. How did she move? She moves on a bearing of what? 70. Where did I say we start our bearing? We start from the north. We start from the north and we move out in a clockwise direction. So I'm starting from the north. This is my north. I'm starting from the north. This is my north. I move in a clockwise. This is my clockwise direction. That is, this is my clockwise direction. Now, what did they say? 70. What is the total of this place? 90. Of course, our 70 should be somewhere here. Is that clear? So I will start. Where did I start from? I started from north. So you say like this. So this place is 070. What is that? That is 70. And mark you, what is the total angle here? 90. So this place is going to be what? It's going to be 20 degrees. Am I speaking to someone? Now, anywhere she reaches, you have to draw your cardinal. Look at the way I'm drawing my cardinal. Good. Well, let us now see. Where is this point? This is going to be our point B. Is that not true? Because it says she moves to a point B. To a point B. What's that bearing from where? They said from again. From B. So it means I'm going to stay here. And I have to continue to turn. I'll be turning until I get a line that goes to that A. Now, let us now see. Where did I say you start your bearing? From the north. Well, let's go. Now, class, if this place is 20, what is this place? This one too is going to be what? 20. That is the alternate angles are equal. If this small place is 20, this place too is going to be 20. If this place is 70, here too is going to be what? Here too is going to be 70. Am I speaking to someone? Very good, beautiful. Now, let us now see. I want to now move my bearing. I start from here. Do we get the line that goes to A here? No. So it means I'm having my 90. It's not there. Can I find the line here? No. That is plus another 90. Can I find the line here? Yes. By what? It means I'm already here. I have to move. By what? By 70. Plus 70. Are we together? So now, the bearing of Sade from B is going to be 90 plus 90. That is what? That is 180. 180 plus this. That is 250. Am I speaking? So this one is going to be 250 degrees. Class, I believe you understand. Is it clear to you? Very good. Yes, this is a very good question. You know, I told you that we have two types of a bearing. This is the other type, that is the engineering. You know, I told you the bearing starts from the north and you measure in the clockwise. Except you are otherwise told. This is the otherwise. Because you can see, you have been given 50 degrees southeast. 50 degrees southeast. here again 60 degree southwest. Not 60 degree west south oh. Not 60 degree west south, is southwest. Now here let's see this question. If you are able to interpret this into a diagram, your problem is halfway solved. Now let's see. Here we have, I draw. Don't forget your cardinal. Please be attentive. From a point on the edge of the sea, one ship 5 kilometers away you cannot do anything. If they tell you a distance from here to Lokoja, from here to Meduguri, you cannot do anything except you get the bearing. What is our bearing? The bearing is 50 degree, listen, 50 degree southeast. See the way I pronounce it. 50 degree southeast. Now here let's go. This is our north. This is our south, this is our west, and of course this is our east. And what did they say? They said 50 degree southeast. Class, where is my southeast? This is my southeast. They said 50 degree. Anywhere you reach, you have to draw your cardinal. 50 degree. Now the point is, are we going to put our 50? They said 50 degree southeast. Southeast. 50 degrees southeast. So it means this place is going to be our 50 degrees. Am I speaking? That is 50 degrees southeast. Now, another is 2 kilometers. What is the distance? The distance is 5 kilometers. Another is 2 kilometers away on a bearing. I told you the distance here cannot lead you to anywhere. Now the answer, another one is a what? Is 60 degree southwest. Let's go. Where's our southwest? Of course, this is our southwest. Southwest. What is that? 60 degree. So I take this place is going to be 60 degrees. Then what's the distance? The distance, of course, is it shouldn't be as long as that 5 kilometers. So here I will draw my cardinal. This is my cardinal. Now, and they said 60 degree. This is my 60 degree. What is the distance? 2 kilometers. Now, the question now says, how far apart are the ships? Where is the first ship is here. The second one is here. How far are they apart? That means you are going to connect this. That is how far apart are they. My dear students, which of the formulae, which of the theorem are we going to use? Sine or cosine rule? Of course, it's going to be what? Cosine rule. Beautiful. Because I know this side, I know this side. Where is the included angle? This is my included angle. And this one, 50 plus 60, that is 110. I hope I'm talking. That is 110. 110 degrees. 110 degrees. Now, let us now try and level. If I call this side A, I call this side B, I call this side C. Of course, this one is going to be small a, which they asked me to find. Small b, of course, is known. This is my small b. And where is my small c? This is my small c. I believe I'm talking. That is my small c. Oh yeah, let us now use our cosine rule. From cosine rule now. From cosine rule. Of course, what are we having? We are having a. That is a squared is equal to b squared plus c squared minus 2bc cos what? Cos a. Now, this one is going to be, what's our a squared? We don't know. A squared is equal to, what's our b squared? That is 2 squared plus, what's our c squared? That is 5 squared minus 2 times 2 times 25 cos 110. Now, I have gotten my values here. Here, that is 2 squared, that is 4. 5 squared, that is 25. 2 times 2 times 5, that is 20. Cos 110, because cos 110 lies in the second quadrant. And cos in second quadrant is what? Is minus. So that is why we are having negative minus 3.420. Now, if I compute this, we have a squared is equal to this plus this, that is 29. Please, I want to sound a note of warning here. A note of warning here. Never you say this plus this, that is 29. And now say minus 20. No, you cannot say minus 20 because you are having multiplication sign. That multiplication has to be dealt with first before you now continue with your computation. Again, never you say 4 plus 25, that is 29. We have written 29. And you now say minus 20. No, don't say minus 20. Because if you say minus 20, that is foul. You have violated the rule of that board mass. You have to do this multiplication first. Now, let's go, class. Minus times minus. This one gives us plus. 20 times 3.420. This one is going to be, if you multiply this, you have 6.84. When you add it together, you have 35.84. Class, you are asked to find a, not a squared. So we now take square root of both sides. So you take a square root of both sides, this one becomes, you know, we're supposed to say when you are taking square root of number, you have to plus or minus. But because we have to find the distance, this can never be negative. So it's going to be positive. That's going to be 35.84. Then what is the square root of 35.84? That is what? 5.982 kilometers. That is to say, the distance of the two ships apart is 5.986 kilometers. Class, if you enjoyed this topic, do subscribe to the channel. See you next time. Thank you.